Hello. Can you hear me? I hope so. Oh, okay. Like that. So, I hope everything works to the extent that I can stream today because the lab has moved. I didn't spoil the fun, but now we can look outside the window and see the bird shit on my window back there. Hello, guten Abend, Sonic. Hello, Yombo. Hello, Dutch. Hello, the Sheepu. Hello, Johnny. And that's it. And hello, lurkers. I will. I'm not finished yet. Let me change the lens. Swap the lens. I'm not changing it. Need to clean it a little bit. Everything is scattered here still, and it's not finalized. I will show you around how the lab is looking right now. So basically that was the sleeping room before, and we just swapped. So this is now the lab. Let me take off the camera. But I have to be careful that I don't show my neighbors here. Alright. Yeah, I think this will be alright. Where is this? Okay, so this is the view outside of my window here in front of the desk. My monitor stopped working, like my HDR monitor. I had to order a new one, that's a bummer. Maybe we can try to repair it, but it doesn't look great. So this is one side. Okay, let me zoom out. This is, here, it's the roof, as you can see. I just placed some, I need a fisheye lens, it's quite cramped. So I had to put this long desk on this side, even though I wanted it over there. So this is the bench for now, but I will put a desk there where I can stand. I can't hear you, peeps. Why can I not hear you? I should be able to hear you now. Okay, let me check. This bitluni still doesn't work. Yeah, I put some stuff just here. There is a bunch of crap on the floor. Nothing sorted, like here, that, but also, there is filament, heat printer. Let me change the... I hope my cable is long enough. Oh no, the power cable isn't long enough. But basically, now I can show you the estate.
I.htpla. Sounds interesting.
Okay, wait. Focus. The window is so dirty it wouldn't focus. Yeah, and there's also a net. Damn it, this is my shed. Let me use another power plug for the camera, and then I will show you around. Like this one here. Because we were talking about that. I'll open the window as well. And we have some moody sounds from outside here. Okay. This is going dark. And I'm plugging it in there. Alright. Hope it comes back. Yes, it comes back. Here we go. So I have 3 windows and some curtains in here. And now the HDMI cable is... Ah! Stupid cables! Yeah. Alright. And this is where the birds are. So my shed, everything there. And there is yeah. Don't mind the window here. This everything there. Das alles wird einmal dir gehören. Was? Die ollen Gardinen? Okay, so this is the woodlands until basically, yeah, this is a big tree over there. Everything, the levels there, everything. This is where the birds are living that you're hearing all the time. I'll do this off kip. And now we are back here. So, wow, why am I sweating so much? It seems to be hot. I switched the audio, the TTS. Hello, Graustreif. Yeah, okay. Hey, Ameboid. Hey, always Rohan. Always FF. What does the FF mean? Oh shit. Destroying our device. Okay, device is working somewhat. So we can close it up. I will show you the last state of that thing. Where is it? Was this the one? Yeah. Here. Okay, I changed the code a little bit so we can, let me press F11 so we will be having a scroll bar, or I unzoom it like that. Okay. So I think it's, oh no, it's not plugged in. I will plug it in. Where is the one? Here. Yeah, I will plug it in. And then we can read it out. So let's connect. I will just erase it. Oops. Connect. Where is it? Huh? Oh, no, it's not the issue. I think I have too many USB devices on this one USB now because I added the microphone. Is the microphone still working? Might be just drawing too much power. No, it's not the issue. Let me use another USB. The front side USB. Yeah, no, I have the microphone is on the same USB. Let me switch the USB ports. Maybe that will work. Nope. Okay. Okay, then let's use the front device here. The front. Oh wait, there it is. Yes. Okay. So too much power draw from the microphone, I believe, then on this one USB. Anyways, No, I'm not moving. I just moved up a floor so I can look outside the window and see and look at my neighbor's house. Like I can see those trees over there. I just don't want to show the house of my neighbors, but yeah, looking at the foresty environment there. Doxing. Foo! Foo, hello Kasper, by the way. Yeah, not for the work atmosphere. Also, it's more convenient for us since we don't have a bathroom upstairs yet. We have only downstairs a bathroom, and having the sleeping room at the same floor is more convenient. Is hue saturation, hello. Thank you very much for the compliment. Is this for the excavator fund, Fu? I will put it there at least. Oh wait, what is this? I need to be careful not to dox myself. And the screen is broken. I don't think we can repair it because it self-destructs. It starts flickering and then... Huh? Where is it? I just saw it. Excavator fund. Okay, here. Excavator fund. Foo. Got it. Foo. And what was it? 4K is 95 cents. Thank you very much. That's 0.2% closer to the target. Is it? No. No, it is. Is it? More or less. Can't read this. Yeah, I have only HD now. Stupid screen is broken. What's with? YouTube is dead. Okay, let me try again. Oh, I see that. Wait. I can see you. Let me fix that. Maybe there is an issue with... I will fix that so we can hear you and see the live chat as well. Somehow this was broken. Okay. Here, the trigger was missing. Here you go. Oh, now I have to hear back. Dollar price is moving fast, what? Bipo. Pillepalle. Hey ja, Mahlzeit. Now chat is sorted again. I can hear you all now. Okay. Yeah. Okay. Oh wow. I'm hearing all you said the past 15 minutes. Now foot of forgotten people on screen. Okay, I think we are connected. Let's rewind. I also might add this light here. can do that easily. At least I have plenty of free power sockets now. Here we go. More light from this side. All right, we are at the target. Okay. Okay. Retest. Here we go. Sync and decode. Ah! Worked. Oh, you can probably see. Should I make it more obvious, the size? So this is decoding. I also made like a few changes that show it's the best. It's checked in, and you can get it on GitHub, the latest code. So more or less reliable now. I show you the parameters. As you can see, we are using only one wavelength per bit. That's cool. I tested it and worked more or less reliable, so we can do that. Then the next thing that wait, this is the wrong code. Platform is this the one? CDC tape. Why is it opening platform IO? Whatever, I'm not interested. Stop it. Main, okay, and 1500 hertz. That's so many bits, since we don't have stop and start bits. And I rebuilt the code, so it has optional stop bits. For whatever reason, we can just remove it as well, because yeah, it's only continuous bits after the sync byte. And that's about it. Oh, we didn't code it, but I want to do the case today. We want to put it in a case now. Maybe I will, I shouldn't do it while it's powered up. We need to replace that connector by something that's not stiff. Oh, just. So I will desolder this one and replace it with this here, I believe. Yeah, hope this is right. Clock, reset, okay, we can solder that. Let me get the soldering iron over here. I can take this one here. And then we will try to design the mechanical part. So what are you guys using right now for? I see more and more for CID. I see more and more people using Onshape. Is this any good? Is it free? Is it such a trap like Fusion? What do you say? I might need solder. Same trap. Yeah. You're somewhat quota limited for the project, or what it was. turn that around. Online trap. Okay. Like subscription based. How do I desolder this stuff here? I might want to just show you a trick. So I hope I don't rip off the pads, but I just pull off the plastic and then we can desolder it one by one pin. Yeah, it was a mistake to put the stiff connector on there, since we will have a solid case at the end anyway, so I might want to use wires instead. All right. Okay. I will just open the window. We have so much air here. More airtime than Tony Hawk. Maybe you can hear the birds, but probably not, because the microphone is around the corner. Okay, this is the reset line. This is, what is this? I have no clue what this is. This is data. So this is probably VCC, yeah. I don't think we even need VCC here. But I will put it there anyways. This is data. So this is the data pin. Then we have clock and ground. Oh no, I don't know where my tape is. I hope I can find it in this chaos. The captain tape. And the ground pin. Oops. Okay. That's it about the soldering today. Now we need to sandwich it. The squeaky chair is still here, if you were wondering. I tried to WD-40 it today, to no avail, didn't help at all. I was thinking maybe I will put a jumper at some point in here, like a right angle jumper, so I can switch from CDC to USB mass storage for debugging. All right. Wondering if I can recall. Go on. Yeah, I will get a good chair at some point, or I will disassemble it and find the squeaky places. But not today. Today is we are doing this stuff. Okay, so let me just scissors. I'm wondering if some heat shrink would be the best here. But then I have to detach it again. Okay, let's do some heat shrink. I want to have it nice. Let me turn on soldering iron again and I will check for the proper size. Because I have plenty of sizes here. This might be the right one. Will it fit? Probably not. Might be tight. Let's see if that fits. If it fits, I sits. This will overheat then. At least we won't have any. Oh, it's looking good, my friends. Looking good. Won't have odd effects by shorting 5 volts to this 1.5 volt circuit here. Cool. Okay, I will shrink it at another time probably. Let's attach the power lines again. Okay. Here, this one and this one. Maybe I will shrink it now. Too much here. Cut off some corners. Hot air station. Still on the floor, my friends. Still on the floor. But we can get it over here. Power cord. That looks like a power cord. Hey Wagon Loads! By the way, here on this wall I might put the ping pong LED wall on, but I'm not sure yet about that. Okay. Yes, data recording is solved. But not, I mean, we have only the JavaScript implementation, I just noticed, for the decoding, but that should be straightforward because I'm not using, I don't even need float at all. I can show you the optimizations that I did. I don't know if I showed it last stream, but it was crazy what I could pull off. Oh yeah, by the way, if you joined later, this is how it looks right now. So it syncs and decodes at 1500 baud. So that's quite good. The data is decoded correctly most of the times. I had an incident today where it didn't work, but oh well, it was probably just a cosmic radiation incident. Okay, so quite cool stuff that I was able to pull off is, do you remember, okay, this is decode byte. We had DFT decoding multiplying, like this is the lower frequency, this is the higher frequency for 0, and this is the lower frequency for 1, and then we're deciding if it's 1 or 0, if the power is higher or lower. So this is where everything was getting more complicated with the binning. If we want to do a streamed version, I don't have paint, I can tell you. This is like really smart. I don't know how I will put it in the video because this is probably quite hard to explain. Why is my mouse not? Yeah, more or less we don't need it actually, because you need like, it might work, it's quite similar more or less. It's like changing, it's, the frequency is the same, you just, the width of the high phase is changing. Probably would work the same. Yeah, we could do it. Okay, so right now what we have, if we have like a time frame and we want, let's say here, this is one bin. What's happening with the mouse? Squiggly lines. Anyways, we have a sine wave like that, and maybe next bit is 0, so we have double the frequency. We have like one from our we have like let's say an area of 8 bits. This is bit 0, this is bit 1, so let's put the number here so you don't, it's actually, this is actually a 1 and this is actually a 0. It's confusing now. So this is the encoded waveform, and to decode this we have like a sampling rate of 32 samples per and it's even more than that, because we are double the Nyquist frequency of this one here. So this is, I think we have here per wave we have 8 samples. No, 16 samples per wave, which means we have plenty of resolution to adjust and fix the sync if it's shifting. So this is also what we are already doing. But if we want to analyze this on the MCU, we don't have enough. We might have now with my trick, we might have enough samples to do the analysis, like, because this is like a quadratic stuff. You need like to decode a whole byte each sample, and then it shifts by one sample. You have like one sample in and one sample out, and then you are analyzing again and see, oh yeah, the sync is better this way or whatever. So what I can do is, like when this window is moving here, the first window, we can do a running sum. So we take this sample value and we subtract it here, and when it's entering the window we are adding it. So this is just maintaining something. This will be a running sum, but the issue is our function for DFT is we taking the sample and multiplying it by sinus with the actual sample, the phase of the sample in that window. So we multiply, in this case it's lined up, we would multiply the sinus here with the actual sample, which might be somewhere else, like here. So we are multiplying that, and this is changing from here. This is changing all the time. The product of the sinus and the samples is changing all the time. So we can't maintain this simple like in and out method for the window. This would save us, like if we have 32 samples, we have like 32 multiplications, and if we could do it like adding each new sample to that, that's one multiplication, and removing maybe second multiplication or addition or subtraction or whatever. So it's only 1/16 of the cycles that we need to maintain the current window state. And what I tested is basically we tried encoding before a square wave, and the square waves are overdriving a little bit, so we are doing like actual sinus. But what I'm doing right now, I swapped it and not multiplying by a square wave, by a sinus, but by a square wave. This is what you can see up here. So for that means we are adding all those samples here. Those are added and those are subtracted, and that works. It's perfectly, I didn't see any difference than multiplying. So we don't even need a multiplication here, and we can maintain our method of the running sum. Why can't I draw a perfect line? In out for each of those sub windows here. Oh shit. Anyways, something like that. So we only need to maintain this sum. This is sum. This sum is basically minus this sum of the samples, and the same is here. Ah, shoot. Quarter is for the 0. We maintain this sum. Oops. Sum minus this sum plus this sum and this sum. So we just remove one element, since we record all the samples that are coming in a ring buffer or whatever queue, whatever you like. We just maintain the current sum of that and can decode super easily on the fly a moving window with each incoming sample. So that works, and this is what we saw here is the result of that. nudge audio to record each byte. Yeah, we tried that, like multiple frequencies, but the density changes, so it's quite hard. I would leave it like that for now, since it's working. Implement that, and then we can try. I can tell you, this is just the beginning. I want to do an even better project with this whole tape recording, and if not with that device, then with our stepper motors and our own am I recording? I hope not. Soon we will invent coke. No, but we can maybe like skip all the trash here. Not trash, I mean, must be a better way. Better way of what? I think qubits, entanglement, bit entanglement, loony bits. There probably is. There probably is. We saw why, like in our frequency analysis, but the reliability might drop. Detecting is so complicated. No, it's not. It's really not. Look at this. This is what's just happening right now. We get this here. This is, oh, sorry. Okay, so this is what's happening. Waves per bit, and here samples per wave. So what it's doing is just calculating, summing up those samples to this, yeah, and then does a different sum for the zero, and then compares which of the sums is bigger, and takes either the 1 or the 0. It's so simple, not a single multiplication, nothing, and it can be done during streaming on really low power MCUs. This one is now even overpowered. We could do it on multiple channels, most probably. We could probably double the frequency. Not the frequency of actual, not the frequency, but we are almost at the limit. I can probably go up to, yeah, we could do, oh, Aaron, this is what we did last time, and it worked with two waves per bit, and then I changed it to 1 wave per bit, and it works as well. So I will take the higher density. If it's not reliable enough to storing data later in a file system, then I will change it, and we will have like only half the density. What we could try later is like increase the frequency from 1.5 kilohertz to maybe 1.8, but at some point like the amplitude is dropping off the yeah, you can see we have, maybe I can show it even. Let me test it here. Okay, let me plug it in. I can show you how it will look like. We change the frequencies. Okay, I will fast forward maybe, or we can rewind. This is just an old thing that we did. Oh wait, connect. Where's the tape drive? We can, I think we might be able to use this to store frequency, but I might have removed it from the code. Okay. this is the frequency right now. 1.5. Oh, this is the old one. Okay, you can see. Trick identity record sine wave, then the readout square them, and it gives you twice the frequency wave with no impact on your data. What is trick identity? Oh, square them, yeah, that's what we did with a Schmidt trigger. So what we could do is, I hope, let me record, and then let's try different frequencies. So you might be able to see. Okay. I hope it's still in the code, because that was like one testing thing. Oh, where is this coming from? Okay, play. This is just from here. These are the frequencies, and you can see it's just, we can barely see anything here anymore. So we lose like the resolution, and I think what is, let me check that. Oh no. So we are here, the resolution is so bad. Let me open test 2 so we can see to which frequency. Yeah, 3 kilohertz is already almost not visible. Let me switch to the other one so we can see how that looks like. The amplitude is lowering, and if we have enough like resolution in the amplitude, we might be able like to normalize it. That's all right. We can normalize stuff on the fly. Each sample just needs one, like each bin just needs a division. Play and read ADC. Okay. Can we see that? No, you can't see actually. Increasing the frequency, you might see, we don't see it. We start. Oh, retest. Oh, this is an old encoding. We are past our test. Okay, retest. Okay, this is, I don't know, a couple of hundred hertz. Let me. This is a higher frequency, and you can see the amplitude is. Oh! Oh, we're Ah. We play it a little bit. The higher the frequency, the lower the amplitude. That's what I wanted to say. See that? There is no way. I think that might be even a switch to a higher frequency. So how do you analyze that? That's not different to noise, really. This is probably here we see probably a sub harmonics, lower harmonic of the one that came after that. If you can see, this is half the wavelength. So you probably get like the lower harmonics at some point. So we actually can't get much of higher frequency. But what we could do, we could try to just double the data density by putting there like two frequencies at the same time. Let's say 1.25 kilohertz and 1.5 kilohertz at the same time, and try to decode those. Might be fast enough to decode on the. Yeah, we did this. Schmidt, we did that last time, Wagon Loads. Schmidt trigger. And this is basically the first time where we had a success. And since then, we don't need the Schmidt trigger because like the decision is intrinsic in the sum. If the sum is bigger than whatever. So we don't need to do actually the Schmidt trigger thing. We would need to do it if we want to count the passes through like the zero level. Anyways, I don't change this running system. We might want to encode a higher density at a later point, and now we want to encase it so we have a nice looking data set thingy. We have some work to do because, okay, let me disconnect that, because we have the mechanic of opening the device as well. So we need to, there is like a small trigger here that we need to use. This stuff we can remove that as well, get rid of that, and we can glue on actually a cap that looks more like the Commodore. Ah! Oh, I bent it a little bit. Anyways, this is stuff. And we need to fold it so it will fit the case as well. Let me film that. Okay, this is what we need to use. And now we need to fold it. I think I designed the PCB so the ADCs will be not on top of the motor, so we need to flip it like that. But the power, oh, we also don't want the power to be there. Oh, this is tricky. I see. Oh, what was that? Something crunched. There is the driver, motor driver, like that. Okay. I don't know, this is also the power. Oh. this is directly on top of the ADCs. Damn it. If we sandwich it like that, it might be noisy. We should test it, otherwise we need to sandwich it elsewhere. Wait, we have some power here. We might need to put it there as well. Yeah, I'm a software guy. You make an analog hardware filter and show me the result. Ah, I'm skeptical. I mean, C64 did it, so I know it's possible. Shoot, how do we do it? This power thing drives me nuts. Maybe we put it over here. You know what? Let's put it on top of that, because we don't have a PCB that we need to sandwich there. Like that. Ah! Ouch. How do we do it? How did they do it? Or do we... You know what? Why don't we just put it on top of it? Like that. Put away. Bend away the screen. And put it here. Like that, sandwiched. Actually, not that bad. Oh no. Yikes. Please don't break. Also, the switches need to stay at the same position, otherwise... Yeah, if we break it, we keep it. You know what, I will just use some tape. Yeah, that's what we will do right now. I have Captain tape, it's quite thin, but it might not be as sticky as we need to do it right. Captain tape is insulating, quite durable as well. So I will put it on the bottom of this, or we use just insulation tape here. No, you know what? I will just use regular tape here. Bye bye screen. Like that. And then I will pull it in over here. This will be good enough, I believe. So it's actually smaller then. Like that. So the footprint is now smaller than before. Yeah, but how do we... Is this the lever? Yeah, it's the lever. We can't glue to that. We can't glue to that. This is this is all movable parts. So we would need to sandwich it like that, but tape it a different way. I don't know how. Maybe like, yeah, we'll just tape it from this side as well, like that. Let's hope that sticks more or less. In that case, yeah, this will stay like that, I believe. Okay, now the power. Let's put the power over here and sandwich, and then sandwich it like that. Ooh, that might work. Pips, that might work. And this is actually the white side of the, oops, sorry. So this might work. And this side can be a little bit wider since the regular C64 is also wider there, but I will this is cool. Okay. Should we? Oh, there is potential of short circuits, so I will just put some Captain tape on top of that. We might even want to put here like that. Captain tape. So we won't short anything, and now we will try to power it on and see if it's still working. Ah! Okay, sandwich done. Cute. Is there a resistor? Where is this coming from? I hope it's not from my PCB. Ah. Okay, I hear a USB sound. All right, it's there. Let's put in the tape. Ah. Oh, we need really to push it back so the lever is moved back properly. Uh-oh. Okay. That's our stack. This is just debugging. Let's connect and see if it's still working. Record test. Wrong direction. I shouldn't touch the button. Okay. I think I need this shot play and then a retest. Alrighty, that works. Nice. Okay. So, Blender time! Let's see how that will look like. This is like this stack is crazy. How do we squish it? Squishy. Wait. We need to fix that, and then we need a button that shifts that. Uh-oh. Did we short something? I should be really careful with that. Once we have like a case, so if we have a button that we press down, it needs to push this down here. Let's see the mechanic. We detach that. So, can we zoom in even more? Like that. Okay, so here is the pin. And what we doing, we pushing this pin back. It needs quite some force. And it moves up by itself. So needs to have some play if we mounting holes. Yes, we have I think here on the back there are two for really small screws, but I think I would like, yeah, we can here, there are also some sensors if there is tape in or whatever, so we need to be delicate with that, but these are really small, so if we print something it would be really thin here. Not sure if, but we can probably put it in a frame such that it won't move around. The only thing that we need to ensure is that we have enough force on this here. We can maybe even fake it by not making the button a lever, but like a push button in this direction. Oh, this is hard. And there is this screw in the way. I don't want even to undo this because we will lose the whole mechanic here. Very delicate. Oh, okay. Caliper. And I think I need a new coin battery for my caliper. Hey Peter! Greetings back to Boulder. Where are the coin batteries? Coin holder. I don't think I even have a coin battery here. Alright, we have to work without coin battery. So, caliper. What's the stack height? So inner height will be 28 millimeters. 28 millimeters inner cavity. We will do some test prints and see what happens. Blender 4, here we go. Huh? Where did it go? Where did it go? It disappeared. Ooh. My Google Drive. Where is my Google Drive? Not. Huh? Okay, my Google Drive is. Yeah. I need to restart my Google Drive. I don't know. Yeah, it's somehow. The drive is not showing up. I don't know why Google is so bad with that. It crashes quite often. Is there a better client for Google Drive? Yes. Huh? Why isn't it showing? Oh, it's probably I need to authenticate. What? It's not showing my drive. Damn it! No time to restart. Okay, you know what? I will just download this file and I don't care anymore. Okay. Give me a second. Yes. Here. Okay, so I started working on it in the train. It will look like actual data set. And then we need to figure out need to find out how to do the lever later, okay? Or we do like a hidden button somewhere here. Or I mean the original device has this thing on the side here. Maybe we will just put it there again. You can see it's just open. It's like a hidden open lever. We just hide it on the side, and we have like mock-up buttons here that do nothing. Or we could actually have buttons that do something in there, but for now I would suggest doing just fake. What did we do? 2.8 centimeters? Was it? Yeah, 2.8 centimeters. So that's it looks good. And the extents of that device are I would say we only need 60 inner. Oh, the inner width is 60. So we need to case thickness should be, wait, do we have, let's do incremental. Increment. That's really not the best editing software for that. 2 millimeters and 2 millimeters on this side. This is terrible cut. This is so painful to watch, is it? Okay. We do just buttons for looks. No need. Where is this coming from? What is this button? What is this edge here? Did we miss something? Oh no, that's the PCB. All right. Yeah, the PCB will be lower. So PCB goes on the bottom, 2.8. Yes, that will be a fake C64 data set. So this needs to be 1 millimeter down, 1 millimeter up. Since we have a thickness of the case will be 2 millimeters, but the PCB Yeah, it is 2 millimeters anyways. Is it? Yeah. Oh, you didn't see that? Okay, I will show you here. This is the device. This is our stack with USB. Yeah, it is compared. Okay, so size comparison. People, time for a size comparison. Almost same data density compared to this one. Let's record for our video. Yeah. We can put this tape, what, 4 times in there? 5 times? Yeah. So this is our achievement, working on that for 1.5 months or what? Something like that. No tape counter. Yeah, not yet. We don't need one. It has a file system, so it will do everything automatically. Rewind, read in the FAT, and then it will present the files as a mass storage, and you can access them. Oh yeah, I didn't record that. Damn it! It was probably recording from before. I stopped it. Okay, I can close the window. Yeah, back to the design. Back to the chopper. Here we go. This is our innards. The device itself, it has a width of, I need to check that. Okay, the device itself, 2.3. 2.3. Okay, let's clone that. Yes. Yeah, you can use it as a drive, but it will be slow. Random access isn't as easily done there. I will probably cache the FAT and write it once everything is transferred or there is an idle phase or whatever. Just lazy writing like in old school USB drives. Okay. Oh, come on. Wait, this is Platina. PCB. Let's do it like that. Since you're watching. Oh, you can see even that part. Anyways. Oh, Z80, what are you doing? You're converting it to a Z80 computer? Seven plus 3. Adam, the issue is I I have code on this. Where's the small device? I did already on a small device because Windows is extending the files and basically inflating the FAT for long file names on its own because it's creating the hidden system whatever directory. And I just removed those. I implemented a method that removes all those long file names and leaves you with the 8 plus 3 at 8.3 file names. So we can save a lot of space by just not saving long file names. Half-inch tape. Okay. Okay, so what was the width of that? Oh yeah, we need all the width here. It's 58. It's not that wide. Proxmox. Hmm. 58. No, it's 58. So this will be 58. I believe it's like this here. Yeah. It's not that great up here, but I think we can bevel it in this corner because up here it's not. Yeah, this is 55. So we can actually bevel these edges here. Yeah. Oh. Oops. Okay, we need to apply scale first, otherwise, and then bevel 1, I think that will do it. Also on the other side as well, don't we want to do it as well? No, we don't need. Actually, I want to. So let's do it all sides. Okay, like that. We need also some space for the mechanics here. This is soft. So I believe we could also bevel those edges here. You know what? We just bevel everything there. Because we have the size. Okay. The size is only because of the soft PCB that's extending on all sides. So this is the PCB, but this is not the cavity actually. The cavity will contain the PCB and the... Oh, wait a second. Oh no! We need to turn around the PCB because the USB needs to go on the back. Ooh. Ouch. Then the ADCs will be where the motor is. Okay, we might need some alu tape there. Damn. Thinking I want me to share. Why move it around there? Yeah, need to move it over there because I want the USB on the back like that. That's better. Alright. Hope still fits. Okay, this is the recorder. And this will be cavity, and the cavity will contain both the recorder and the PCB like that. We will do the opening for the USB as well. The USB is centered, so that will be easy. Oops. I think, yeah. No. This is the PCB. Okay, we need the USB port. So USB port. USB port is let's use 10 millimeters. 10 times 4. Oh, right. 4. 10. And let's do here. Also 10, that's good enough. We do it like that. It should protrude the case. Live scale. Okay, that looks alright. Now, oh wait, does it? Doesn't go through the piece. Actually, we need to move it up like that. Maybe 0.5 millimeters downwards. This is correct, I think. All right. So, faces. I need those faces, and then no, I don't want those faces. I just okay. I need edges. Edges. Don't want those edges. Just want those edges. And then what was it, 4 millimeters, so we need more or less like that, something like that. That's 1.9, yeah, and then some rounding, so let's do 8. Oh, yeah, whatever. Okay, so this is our USB. Now I need some opening for the USB cable, which will be just a copy USB bay. Let's call it USB bay. B-bay. And then we can scale it. How big is our cable here? I would say it's 6, so we add 2 millimeters, it will be 8. 8 by 11, so 11, 13. 8 by 13. So 8 by 13. That looks, yikes. I don't like that. Maybe I will start from square. The audio jacks won't do anything since I disconnected the output of the amplifiers. Oh, the output audio jack will work, but the input microphone won't work anymore. I disconnected the recording head from the amplifier. 6, 8, 8. Okay, you know what? I need to use a new box here. And start from scratch. How is it? Add, no. Shift, add, mesh, cube. And we scale it. Eight by 13. Wait, wrong 8. This 8, and this will be 20, whatever. Okay, apply scale. Oopsies. Okay, now we need to do a new. Oh wait, we only need this side here. Bevel and do, what is the bevel here? Three. Okay. So this should fit. Hey Mylind, I'm doing fine, how are you? Oops. Let's move that. We need 11.5. Like that. Move it over here. Wait, where is the PCB? This is the PCB. Okay, this needs to move out a little bit. Ooh! and this needs to move. We have like 2 millimeters case, so well, shift is so strangely. Okay, yeah, we, since this is only a hole, yeah, this also needs to go down one more since we are clipping it, and we also need needs this we need to add a cube. What? Who? Think. Wait. Yeah, Blender isn't like the best choice, but my Fusion account is basically saturated with other stuff, and I would need like to delete something, and it's annoying, and it's always acting up, crashing, whatever. My trusty Blender always works. It's sufficient for my stuff. Okay, well, let me do it like that. Yeah, no, I'm not interested, really. I haven't. Okay, so this is just the wall thickness. Blender is quite easy to learn. Where's my pivot? Oh, it's up there. Okay. 3.5. Okay, this is just the edge. And then we have 2 millimeters. It's a little bit, okay, so let's do 7, even though it's a terrible number. No, okay, let's do 8. I know you hate the 7s just as I do. All right. Let's clip from the, we can. Hey, Nariño! Hello. So this is how, let me do the Boolean operations here. Oh, we have already some Booleans here. Generate Boolean. Then we basically subtract difference, and I will use the inner cavity here. Then I will add Boolean. I will union this cube, which is not USB case wall, and then this was a USB bay, and then we will subtract Boolean generate difference that. This doesn't need to be visible anymore, this doesn't need to be visible anymore, and this needs to be subtracted. This is not the best way. We should just group stuff because that's too many operations, that consecutive operations at the end. But this might work. Let me remove that USB collection. Now look at that. Everything is in that collection. Okay, so this is how the USB port might look like in the end. Let me do solid. Oh, look at that. You see that? We need to fix that thing. Alright. I wouldn't see that. So this is case wall. It's just protruding here. Yeah, we can shorten that because we don't need it that low. It just needs to be 0.5 is good enough here. All right, let's close that. Z solid. I don't know, is there this plugin that shows my key combinations so you could actually learn how that looks? Is this wide enough for the USB cable? Yeah, we have some stuff inside there. Oh, why is this? Oh yeah, since I changed everything, I should move up the other stuff as well. Let me change that wireframe. We have, that's the recorder, that's the PCB, the lamp. Yeah, we can move the lamp. Front face. Yeah, no, never heard of parametric CAD. I don't know what you mean. What is that? (14.15.9) front face. Where are the buttons here? Or is recorder USB port, front face, Commodore, case, camera, button frame here. Button frame is here. Needs also go up. So 16. Yeah, open SCAD. We need to type it then. Look at that. Here, done. Look how easy it was. Easy peasy, pips. We're done. All right. I will cut. Do an opening here. How do we do screws? Do we have even space for screws, or do we just shut it with? Glad that you asked. I will show you here. Boop. I just stole an image from Wikipedia. Is it opening? Oh, Inkscape, please load already. All right, so where is it? Yeah, this is basically the image from Wikipedia, but I did a little mistake. It's not fine enough. Maybe we can fix that. So basically what you can do is you have the image and then trace bitmap. Oh, I need to wait. Wait, Foo. Trace bitmap. Yeah, I need to hide that while we are tracing the bitmap. No. Where am I? Let's hide that. Oh, it's so long time ago that. Yeah, you can try. Use the image from Wikipedia. It's the best. It's the original one that I also have here. Why is that? Why is this here? Wait, here. Properties. Ah, where are the? Oh no. Okay, let's start again over here. Trace bitmap. Huh? Why don't we see it? Brightness, probably because it's not bright right now. Where is the trace bitmap? Ah. Oh, here we go. You can see it here. I can't see. Can I zoom in somehow? Multiple scans. Smooth. No, not multiple scans. Option, speckle, smooth, stack, remove background. No, single scan. Can you 2D print the label on the case? Yes, I can. I have the AMS, so yeah, but is there also the C with the logo? I don't want to do all that stuff. I will just rip it. Otherwise, I can take a better image with my scanner that's not as warped as this one is. Okay, wait. Okay, let me just apply and then see what we get. This. Ah! Yeah. Maybe. Options. What is speckles? Smooth corners. No smooth corners. Optimize. No optimization. Update. Apply. Okay, I want a very crisp oh, it's still, oh no. Smooth corners. Yeah, okay, smooth corners. What is speckles? Does it say anything? Oh yeah. Okay, yeah. Ignore speckles. Like 1. Or maybe not. Maybe not ignore speckles. Smooth corners. Smooth out sharp corners of the trace. No. Let's do full thing here. Apply. Bam. But I really don't want to mess around with that. The print won't be that high resolution anyways. So you know what? F this. Don't want to deal with that sidetrack here. We have something that looks good enough for now. And it's already applied to this thing here. Anyways, you saw how I did it. Why on the train. Now the thing is, we should try to print maybe this whole thing. Add mesh cube. Oh, you know what? We might have some space on the left and the right. Or we might want to make it a little bit wider so we have space for some screws. But for now, I will do width is maybe, but I will place the eject button somewhere else. Or the whole thing will be one button. Because I mean we need to do the mechanics on this side and it's quite hard to press and the buttons are already quite small. So either these will be fake and only the eject will work. Oh, by the way, I see that the buttons needs to be narrow here. They're too wide, this button thing. Anyways, let's do this 60 and do like 40. Let's clip it so we can test the whole thing. We will just print a mock-up. Add modifier. Or should we intersect? Wait a second. No. We do the following. We take this, we move it down, and we intersect that. So actually, like that. This will be bottom case, and this is just, there will be no connection whatsoever. Oh, see, I have springs here. Yeah, now I will just generate boolean and then intersect with the case. Okay. Oh, that didn't go well. Fast did work. Uh-oh. It's not a good sign. Okay, let me hide this one here. Also hide that. Hide that. Hide that. Buttons. Button frame is wrong anyways. Okay. Wait a second. Why do we have, what did I think here while doing this? Wait, show me the PCB. The PCB is in here, but we need actual corners down there, maybe. Yeah, we need actual corners there. Maybe we should also take the case and then generate Boolean difference and then the PCB from that. So now remove the PCB. Now the PCB will sit in there like that. No clips, no nothing yet. Is this 2 millimeters? Wait, this is not 2 millimeters. The cavity needs to be bigger. Why is it so small? Cavity needs to go up to here. Here. Two millimeters of case is good enough. Corners are also right. Now this is, oh, huh? What did I do? Oh no, I only moved one part of the cavity. Let me change to wireframe. No, I need the cavity. Yeah. Nope. Okay. All right. And now the PCB has no, maybe we'll put the cavity not as low as the PCB is. Where is the PCB? Show me the PCB. This is the PCB. This is the cavity. Okay, so let's move the cavity one up. We will have some meat for screws maybe on the side then. Oops. And the PCB, I don't know if it will fit. Probably we need to make it slightly bigger. Where is this PCB? Here. Slightly bigger than that. So we need a little bit of tolerance. So dimension 4 and 4. 0.2 millimeters to each side. And then let's render it solid. PCB. This is how it looks like right now. We'll sit there. Now let's print this and while we are doing other stuff. What is this? Oh, Should we make it higher so we can see this thing? Bottom case. Really? That's cool. Should work though. I mean, it's oops. It's fast enough for that. Even though it's Python. Why is it? Nice, welcome. All right, here. Okay, we have a lower case, bottom case. Let's save that. Export STL. Selection only. Bottom case. Bamboo Studio. I don't think my printer is even connected yet. So let me plug it in before we can continue. Ah! Where's the power? Going in. All right. Okay, printer is plugged in. A new configuration package is available. Okay, let's take it. Let's see what Bamboo Lab says. Okay. Yeah, whatever. Let's see if that will work better. Downloads 200 megabytes. Squeaky chair. It doesn't work anymore. Yeah, that's what's usually happening. It's sabotaging me. While it's downloading, we can still prepare it. Prepare. Bottom. I do. Here. Bloop. Hey, it's here. Okay, PLA met. Change filament. Here we go. Sliced plate. Print plate. 28 minutes. Should we do a preview quality? Diameter, flow standard, generic, weight smooth. How do you change? Standard, optimal, draft, extra draft. Yeah, we save a little bit on that. Print plate. 25. I will give you information in a second. Let me just start the print. Yeah, it doesn't matter, standard strength, yeah, whatever. Here, slice plate. I will repeat myself because I showed maybe something in the beginning, but time lapse on, off, on. I have no clue. That's. I hope it doesn't. The filaments don't break in the EMS. It's a pain in the ass to take it apart and remove the debris. Okay, printer starts. Ah! Cleaning tower. Oh, really? Uh-oh. It complains about something. No, no! No lubricating lead screws and no firmware update for now. Just print it. I got a new print bed, the one super sticky one. So I hope this will work. Okay, so here is an update for a new iTestthings. Hello. New people that joined. You can see here. What you can see here is a micro cassette recorder that we attached a new printed circuit board to it. So micro cassettes, recording devices, and we made our own PCB that looks like that. Focus, focus, focus. So let me zoom in the focus somewhere. And it has some ADC or DAC and a USB microcontroller, and we are able to store data on this, like the C64 dataset, which is way bigger. And this will be a USB device. And what we are currently trying to do is to make the case for that. I will show you maybe the encoding results here. Here is our test that's run. That's actual recording that we put on the tape by recording test, and that's the read back of the stuff that we recorded, like encoded bits, similar to how C64 did it. High frequency or double the frequency is 0. Single, like regular frequency, is 1, and this encodes like sync and decode, and you can see it decoded the bytes 0 to 31 correctly, and we can see the signal strength, even though we can see 8 is quite low here, so we almost lost our sync around here. It's quite weak, the signal. Something was going on there on the tape, but we still managed to recover the data correctly. Wibbly wobbly. Let's see, and now the case, if we look, not the cavity, Commodore front face, yeah, we're trying to print it like that, and I'm doing now the bottom half, so we can see that the PCB fits, everything fits, and we can try to improve that now. But I wanted to do something else. Wait. No, they're not all retro related. It's always some part of tech that interests me, but recently retro stuff is quite interesting. I mean, I had always a little bit of stuff like that, like VGA. lot of VGA or PAL encoding and decoding, stuff like that. I don't know, we did a lot of projects. Maybe you watched one of my videos on the main channel. Alright, yeah, I'm using Blender. I'm sick of the other ones. What's complaining? It complained about something again. The build plate marker was not detected. Oh, what? It's here! What? Network. I'm on Wi-Fi here. Yeah, no, it was on my side. Sorry. I hope it resumed quickly enough. It seems like I bumped into my Wi-Fi receiver. I don't have Ethernet here in the upper room since I switched the rooms, if you missed that part. And it's right next to the printer, so I lost my connection. Alright, we're here. Let's see, let's watch the printer if it does anything. Yeah, I know. Oh, streaming elements. Okay, does it print? Does it do anything at all? What do you mean with 5G will be available cheap soon? Not here! We don't have 5G here. Let me check. No, we have only LTE in the village. At your place, you mean? Realtek designed the chip? Oh, alright. That's cool. Oh, you can see the LiDAR. Ethernet. 5G Ethernet. Oh, wow, that's cool. The printer is pretending to fool us. Yeah, I have no clue what it's doing there. Oh, it scanned the line that it just printed. Yeah, it just LiDAR'd the line. Will it finally start? Yeah, I think it started to print. Thank you, printer. A Wurst. Yeah. Here we go. Alright, so the mechanics of the lever of the buttons, or where do we put? We will put the, I think we will put a lip on here, and then we might not even do the corners, or we might, I know, I'm lazy, I really don't want to, but we can put on a lip between the upper and lower case. We have like, oh yeah, there's not much here. I might just do one here, lower uppercase, and then put some screws from the bottom that, since our recorder, but where do we put the mechanic? The mechanics, I don't know, maybe we will manufacture them, like make them from metal and pivot them. barely see it. Yeah, this is only 1 millimeter. How do we do it? Whoop. Huh? Oh yeah. How do we do it? Okay. So this is the upper stack. Let me measure where this nupsi is. It's 9 millimeters from the top. And 30 from the back. Okay, so I will add a mesh. It's a cylinder. Where are the buttons? Button frame. Hey Dusty. Okay, so we rotate here 90. Yes, it's working. It is improved. It can restore data reliably, more or less reliably. What did I say? I have already forgot, damn it. Let me measure again. It's 9 from the top and 30 from that. Okay, so from the top of this part, oops. Okay. Z. From the top, it's 9. So 3, 4. That's 9. The diameter is only like 1 millimeter. I would say let's leave it at 1.5. So we are. Oops. That's the nupsi. And I think we need to move it in a little bit. This is where. And that needs to move. Oh yeah, 30, which will be, this is exactly 30 from, no. Wait, from the back. That's 2.5. 2.5. Is it completely or? Yeah, I think this will be alright. We need. Yeah, we have like 2 little mounting holes that we can do. No, that's only 2 that we can use. Might be some on the bottom. We could try to sandwich, like put a layer that's basically putting it in a frame, wrapping it up like that, but I really want to squeeze like everything in there. so it fits in a tight manner like this. Like really small and tiny, so I will probably use these mounting holes here like 2 little mounting holes and the original screws from that, which I still have. The original ones will be too short, but there are ones that are a little bit longer. I can take these here. Yeah, I have 2. So we could use that. I just need to figure out how do we do this mechanic to open it. So we need to push that. Let me check how far we need to push it to open it completely. Yeah, it's more or less 5 millimeters treble. 5 millimeters treble. Okay, so I will duplicate it and then we will shift it. That's 8. Here. So this is what we need to move. The issue is if we have like a button here, we don't have a lot of space. Either we move the whole thing over. Okay, let me do a collection here. New collection. Nope, see. You can see. Nope, see. Nope, see in. Okay. That will be here. Nope, see in. And now we can move the whole collection. Back because we need space for more or less like that, maybe even 0.5 millimeter more. Yeah. Okay, so we have space for the buttons, and now I need just a cylinder. Oh. Where's the cylinder gone? Huh? Okay. Is this in the oh. Yeah, weird. Sorry. Okay, here we go. Lever. Servo push rod. Oh, that's not a bad idea. Interestingly, I would. Yeah, what? Let's do. Oh, we don't have enough. Let me do this first. Sorry. It's 10. 20 maybe. So where's the pivot? If we want, no, it must be way bigger. 30, 30, and pivot. Let's say we have a pivot here. Here. No, the pivot needs to be in the center. Just about there. So radius need to be 40, which still fits in the case. Yeah, that looks alright. So we have an axle here. We could save a little bit of headache doing it like that. Even here. Where's our case? We need a little bit of meat around our lever here. So this is the furthest we can do. So I will probably rather do it center. I think it makes more sense. We don't need to actually move that far. So oh really? Yes, I should. Bitluni is the main channel. There will be the lever. If we press down, you know what? We could do like print this whole contraption. Oh no, the buttons, it will be hard to print, otherwise we need like support. Like all the buttons will be eject. Wherever we press, it will just engage the lever on both sides. Let me intersect. We can just use editing here. Now let's intersect. Or do we design a lever around that? Yeah, we can do that. It will be easier. So basically, what we can do, there will be buttons. Sorry, it's a little bit confusing right now because... Oh, wait. Okay. Let's design the lever now. We need also the axle, so duplicate. This will be pivot, and this needs to be here. Button pivot, it's just Oh no, it's not just here. Minus 20. Make the rod slide. Yeah. Told you so, told you so. It's, I'm around for a few years now. Oh, wait a second! Is it channel birthday? Or is it 11th August or maybe even 12 years now? Let me check. Where's my channel created? We need to celebrate a birthday at some point. When was it created? Whoa! Wednesday! Wednesday's channel birthday! Congratulations, Wagon Loads! Happy birthday to you. Peeps, we can celebrate on Wednesday! I will get a cake, okay? So, 2013, it's 12 years! Wednesday's birthday! Alright. Yes, perfect timing. Because I don't want to do for a long time today. But this is amazing. This is good news, actually. Good news. 12 years. A foundie? What is a foundie? What is a foundie? Okay, this is the Excel. What does foundie mean? Fondue! Oh, you mean fondue! Oh, I don't know. Oh, wait! I have better ventilation up here, since I have like 2 windows. Yeah. We might want to do a cheese fondue. I need to set up a camera then. Alright, so Excel. Then this is just mechanical. Where's our cube? Cheese but yeah, actually might be. Where's the cube? Cheese fume, yeah. Cube, there it is. Recorder, no, that's the wrong collection then. Here. Cube, that's the lever. If lever is pronounced like that, no clue. Okay, let's. What is on Discord? Yeah, we have Discord. Accurate. Yeah, actually, my lungs. Probably. What is the average lifetime of a Swiss person? The ship, can you tell? Okay, so I assume we will do it like that. Let's assume this is our lever. Wait. Let's move that. I can let's say male. Two millimeters, let's do 4 millimeters. Oops. Extrude. let's do that. Extrude. Extrude. I know it's terrible. Extrude. And extrude. Bam. We need to round over these edges though. Like that. We can move those around. We can move this one around like that. We can move this up. We can move this one in. It's not needed to be like that. Oh! Let's not cause any strange things. This is the lever that should be able to. Also, it needs to go inside of the case a little bit. Oh shoot. Yeah, we need to box using yeah, it is painful. Oh, our print is done. Here, our print is done. Ha! Ooh. New build plate. I got this sticky one. Ooh, sticky. Nice. How do I get the debris off? Come. Discord is linked in the description. Should be. Otherwise, it's link.bitluni.net/discord. All right, I got it off. Oh, cool down. All right. Here we go. Now let's. Famous French quote. What is the famous French quote? Yeah, that's the one. Here we go. All right, peeps. Let's get it on camera. You have been live there. Okay, let's do the first test for the PCB. Does it fit? Oh, we have like the wires here, but other than that, debugging wires. Finicky. This tape is annoying with this unit. Okay, I think the debugging wires take too much space here, so I can't get the USB in. It's so terrible with all the wires here. Okay, do I have to remove the tape now? Just for this purpose. Can I squeeze it in? Does the PCB even fit the case? Yeah, it fits there. USB. Oh, the wires. We can't fit it quite well there. Yeah, the debugging stuff is annoying for the fit test. USB might be. Should we remove the USB, the debugging stuff, to do the fitting test. I'm willing to, since we are not coding today anyways, willing to remove the wires so we can fit it. It's hot now. That's the best we can do. Alright. Now let's try again without the wires. Will it fit? And we need some retention there for the PCB as well. I didn't do any mounting holes because I'm too lazy. Ah! No, doesn't fit. We need to assume the PCB is 1 millimeter higher, so maybe you can see it doesn't fit that well. Yeah, we need to shift everything 1 millimeter higher and do a retention. That's why we do a fitting test. You never know for sure because on the back side of that we have soldered wires, so there are like pins sticking out, which are, I mean, we could do, wait a second. I have an idea. So what if the soldering points, we can plan them in. Pogo pins on the bottom, I could. You're right, I could put it there, even solder on the wires afterwards or whatever. I could even do like a bottom case that has just an opening for pin header or whatever. So that's totally possible. But what I will do right now is I will take the PCB that we have here, and first of all, no wait, the USB port, that thing, the USB bay, need to move everything here, and the wall, all those three things needs to go 0.5 millimeter up. So we go 0.5 millimeter up, 0.5 USB port. Also my 0.5 millimeter up, and that bay also goes 0.5 millimeter up. Okay, like that. Wait, did it go up already? Alright, so we do 0.5 millimeter, and then what else we do is, for that we extend this thing, basically apply scale, and then do the following. Okay, we change that. Oops. Why is it? Why is it so strange? Oh yeah, we changed this to 4. Let's remove that 4. Okay, apply scale. Still strange, 22.5. Okay, let's do 12.5. That's 3 millimeters. 3 millimeters. And there is like 7. Okay, so this actually needs to go up 15. This go 3 millimeters. 2, 3. Extrude 3. This extrude 7. Then we need to move this in 1, 2, 3. Extrude by 3. Then we need to move this in 1, 2, 3. Extrude by 3. All right. Now we take a look at the face here. Then tuck rubber or TPU machine. What? Rubber? What? Welcome, by the way. Now I will take these here. Oops, wrong face. Wrong face. Wait, I can select them like that and just undo this. Okay, like that, and just remove the selection from here and then extrude by 0.7. Okay, here we go. We have enough meat on the bottom to have it like that. So this is our new case. Export STL, bottom case, export STL. Then let's go here, prepare, reload. Reload from disk. Can we see a difference? Oh, you can see that here. So we have now, for the soldered wires and for the USB, we have basically like 0.7 millimeters. Oh, but why is it? Oh, we need to add back the stolen 0.2. Why is it? Let me check that. Oh, actually, that's all right. 0.7 it is. We need to add the 4. That was a good fit, even though it's strange now, but all right. I read. Oh, export. Sulla RTSC compares una botella. I have no clue. I'm not so fluent in Spanish or whatever this is. For maybe even Portuguese. Okay, yeah, it's got a slightly bigger slice plate and print plate, and let's do, yeah. Hey, you test things. I'll come back. 28 minutes. Oh, okay, that's the last print that we do for today, last fit test, and we see each other on Wednesday for... Oh, one thing! While it's printing, we can do one thing. We have this broken recorder here to improve my karma, since I'm butchering this nice little device. We got the belts, and we can revive this recorder here. Oh no! All the screws just fell out. So we can put back on the new belt. Rebelting, yes! Yes! I need to open this, I believe, to be able to put the belt in there. Just don't want to destroy the wires. Okay. This little screw, can we push it up? Not enough. I will just bend it up. We ordered the belts last stream, so we will be able... Who can do it like that? Damn it, who put the wires there such that I can't access it properly? Ah. Okay. Yeah, we don't need to... Oh shit. We don't need to fully open it, just to... Yeah, this one is... Okay, what kind of tension do we need there on the belt? Do we need some like... Does it need to be... Oh wow, that's quite some long ones here. Is this correct? No, this is too long. Way too long. What? Okay. We have plenty of different sizes here. Still too long. What? Yeah. Way shorter, way shorter. How is this even measured? Some tension, but not much. Okay, let's check this one. Maybe I need even like to use the smallest one. Okay, I need to use the smallest one. Here. Yeah, this will be alright. But I think we had some debris here. Did we get all the old sticky stuff? Let me use my tweezers, butcher my tweezers to remove the remaining gunk. Otherwise it will be like really, oh no. Yeah, there is some gunk. The old belt. Yeah. I mean, we won't use it as a IPA. Yeah, I don't have the cleaning supplies here. Resume printing, yes. Problem solved. Here we go. Do I have my cleaning supplies here? No. Can't do it like that. Okay, that looks alright. Here, this one is terrible. This will be ironing a lot. Eh? You follow. Hey, Joe's or yours or whatever, however that is pronounced. Let me improve my karma by reviving this old device. Yeah, if it's ironing, then we will improve it later. All right. So. Anyways, I can just screw it down so nothing is loose here. But we can just move it on. Okay. All right, that looks good. Now some AI bots maybe. They're testing the AI bots in the field. Okay, now we need to be sure to get everything else right, because I forgot everything since last time. Uh-oh. Oh yeah, there are some screws in here. Damn it, I forgot. Shoot, which one was where? These were two. Wait, what? Melt the belt. What? If we have some spare screws, that's not that bad. This one is quite long. I can't remember where this one goes. Okay, let me check. There is still one in here. there is one that's short. Oh wait. This one. Oh yeah, we need to mount this back here somehow. There is a screw. This goes in here. I have no intention to watch back my stream from last time where we took it apart. Somehow this must fit there. Oh yeah. I can see. That feels like it's quite dark. Let me put oh wait. Yeah, this wire. Need to get it out there. Okay. Now it's easier to put this back in where it's supposed to go. But it's still tight. Which wire is so short? Yeah. Painful to watch, huh? Okay, we got this PCB in. Okay. Put the case back on. So there must go a shorter screw. We have a, oh, probably this one. Yeah, we have some spare screws, peeps. That's always good. This one will go there. Then we have I guess this one, yeah, that feels like this is alright. And now the issue is we have 3 different screw lengths. And I know we have 2 screws there. We will see how deep they will sink in. We have an impression. We start with the shortest. Okay, it doesn't bite. Shortest doesn't bite here. Longer one also doesn't bite. So this is probably the spot for the longest one. That feels like it's for the longest one. We should maybe test it first before we do anything else. I have some batteries here. Double A? Yes. Oh, it rotates. Yes. Okay. Do we forward or what is happening? Here we go. Maybe we can listen to our... Okay. Change direction. Uh-oh. Ah! It's not sitting in correctly. But it's rotating. It's the belt? Maybe we need even more tension with the belt. Yeah, I think we might even need a shorter belt for that. Or that one is slipping. Okay. Batteries are low. Okay. But I know that it works more or less. I will just screw it together and then get better batteries for testing. Let's test this screw. Okay, this is not long enough. This will be. Nice trick. No, also not long enough. So we have somewhere is a screw that's too long. This one goes in here. So not sure if we might want to swap these two and try again. I hope I'm not protruding somewhere where it shouldn't be protruding. It feels like this one could work here as well. Yeah, that's good enough. Yeah. Okay, bye-bye, Johnny. Oh no, you're going to tear down video of that thing now. Yeah, this is alright. I think I might have taken too long one. This is our data. This is our data, but the batteries are low. We can listen to our data. Do I actually have more batteries that are... I only found one. Everything is still packed, so I have no clue where the batteries are. On the bottom of a big box. Let me try a different one, maybe this one is better. slow down. Okay. Volume down. We repaired it, peeps. It's repaired. Nice. Revived for 20 bucks. Recording device. So that was a fixing thing. Now I have plenty of belts that are quite long. Yeah. I think we would need to rewind. Yeah, let me rewind and you will hear this is probably more like that. Oh, that was what we recorded before, like this increasing frequency. But the beginning, this is the 1.5 kilohertz. It doesn't sound like 1.5 kilohertz. Hallo. Hallo. Straight from the horror movie. I might take it apart and take a smaller belt, or it's terrible, terrible. I think I need to recharge the batteries or find ones that are still living to give the recorder more juice. How is our Bamboo Lab thingy? Oh, still 9 minutes. And I have plenty of belts. If someone needs a belt, ask me. I will give you one for free. But you need to pick it up yourself. Alright, cool! Fixed it! Yes! I think I have even like a leather case for that somewhere. Oh, wait a second! What is this? Recording this on the Voyager now. Sounds like the recording from Event Horizon movie. Oh, it died. Okay, this battery is also down. But the beginning, you were able to hear that. Yeah, so this is about it. Wax cylinder, yeah. Do you watch? Did you see like where like the scientist from the museum or whatever brought a wax cylinder and then it basically exploded in his hand because he was so nervous on TV. That was funny because he did a mistake. 6 minutes. Last time I pressed like the play button, my Wi-Fi crashed, so let's not do anything. Alexander Bell. My shrink wrap. Let's remove that. Yes, there should be. Oh, there is another belt that I lost. Plenty of belts. I can fix devices. Right. Cylinder. I try to find it for you. Here. Wait. Okay. Let me put it on loud. Or we turn on desktop audio, okay? Here we go.
Yeah, just found it, lol.
Here.
So this is a one-of-a-kind piece. There's no other one like this particular one in the world. And you can see the tracks go this way. And it's really cool because it records much more accurately than... Oh, shit. Oh, my God.
Well, that does happen every once in a while. That can't be good. Now,
Hands trembling.
Are you done with that then?
Yeah, I'm done with that.
All right. Apparently, we're really done with that one. Now,
Oh no, that poor guy.
My
He
tablet was
almost
plugged in all night and it is at 53% at 5:27 p.m.
he
Zordon.
almost said, "Oh fuck."
Shit.
Did you hear that? Oh fuck, shit. Poor guy. All right. In a second, we will know if our
Lol.
stuff is stuff is working. Yeah, this is a child-proof channel here. We're not cursing. If I say fuck, I mean like F-A-K, not C-K. Like effect. Oh, fact. Fact.
Fuck you.
Fuck right.
Farked. Farked. Yeah, right. Farked? Yeah. Okay, when? How much? 3 minutes left. And we can go home. We can go to sleep. That was a birthday. Next Wednesday, in 2 days, come back at 8 o'clock Central European time, summertime. And we will be streaming birthday. Channel birthday 12 years. Whoa. Phew. That's amazing. Such a long time doing crazy projects here. Thank you for sticking around. Many of yours are like here. Since when we are
I
streaming?
had a website
we can
named
check for
FAQE
that.
FAQs.
Hunt tomorrow.
Let's check when we started the live channel. I mean the trash, it was trash channel before, but I can check. Oldest is 8 years ago. Oh wow, okay, but that wasn't with audience. 6 years ago. Oh, there was recently someone. Twitch was Hangout tomorrow. Yeah, we will have Hangout tomorrow. So
You don't
Twitch
look any older
was,
than one day over 12 years on
I
YouTube.
edited when
Semicolon, closing
I
parenthesis.
discovered how we can stream on parallel. But the basic, oh, this one was crazy. This one was crazy. Pick and place machine. We can check, maybe we can see who was there. Prusa. Geekoid. Okay, yeah, that's just troubleshooting. There was nobody there. Look at that whole stream, 40 minutes. I changed. Wait, oldest. I switched the temperature sensor, which was broken. Do we have chat here? Let's see when Johnny joined. Can we see the chat? How do we see the chat? Michael! Electron Ash.
Time we spent
Sienna.
on that, if you count like
Wonder Wolf. Peter! Peter from Boulder is here. This was 5 years ago. Jet.
How old is your SMS smoke detector?
Smoke. It's packed up in the box. I moved twice since then, so
like
this is wow, wagon loads. That's a long time ago. You checked the old videos, or did
that's not
Andy Colloway
but
was also there. Okay,
for the
let's
mini
check. But basically, since 2 years, 5 years, people joined on a regular basis. This was 5. Let's check. PZ. Yeah, we are doing
I enjoy-
audio. PZ was always helping with anything that had to do with audio. Bachler. Oh wow. Yeah, some long time supporters
There.
as well.
Thank you for your support on guitar. Since this is
nice.
the limit, the 40
Dustin.
megahertz that we can reach with the
Oh yeah, here.
I2S
Campfire
and
also supporting for
that's
long time on GitHub sponsorships. All right, our print is done. Let me switch to that. So let's celebrate roundabout like live streaming for 6 years, 5 years, and 12 years YouTube.
Hey guys, how is it going?
Hey Artem. Yeah, that sticks so well. Boop. All right. Even though it's draft, it's already looking for me like it's ship it quality. Look at that. Okay, black doesn't show that well. Let's check how the fit is. All right. Second fit test.
I joined
Now
Twitter
we
in
have-
2008.
We have the cavity for
Nice,
our
it's
pins on the
RPLO.
bottom. And
The
now-
design is
oh,
very
yes.
human.
Look at this. Oh yeah, this is perfect. Perfect fit. Maybe even no, it's perfect. The PCB, we can do like a retainer here or something on the side. Other than that, I could even like glue it down. That's amazing. It works. That
It leaves a
will
nice
work.
texture on the 3D print.
Okay, let's check if the USBs also. Okay, so we did half of the first bottom. Then with the lever and everything on the top, it will be big like that. Compared to this one.
Small reminder, desktop audio is still on stream.
Oh, yeah, you could hear. You were triggered. You were triggered by the plugin noise. Thank you. Okay. Thank you everyone for joining the stream. I see you on Wednesday celebrating 12th year bitluni's lab or bitluni or whatever. Yeah, I will just do like retainer on the sides. remotely. Alright, peeps. I see you either on Hangout on Discord tomorrow evening or in 2 days. Look at it, my Pixar shirt. Or in 2 days for the channel birthday. Bye bye everyone. Have a good night.